Namaste and welcome back to the DSA class. Today we are going to be solving a really interesting question. The question is to find the nth number whose binary representation is a palindrome, right? So some people shorten it and say nth palindromic binary representation also. What does this really even mean? I will tell you, but before that let me tell you this question is one of the favorite questions in an Amazon interview, right? They ask it multiple times, even in other product-based companies. But what does this question mean? First of all, for a person to understand it will take some time, and then to come up with an approach is really difficult, right? On the spot in the interview to come up with an approach for such a problem, you have to be a next level genius. If you are, great. If you are not, then what do you do? What you do is practice before approaching the interview, right? So exposure to many such questions before attending the interview makes the chances of a similar question being asked made really high, and obviously your chances of clearing also goes up, right? Any which way. Now this question comes with a note, guys. This question comes with a note. Look what the note says. Consider the first number whose binary representation is palindrome as 1 instead of 0, which means the first number whose binary representation is palindrome is 1. 1 is not the number, it is the binary representation, which means this is the first palindromic number. I hope you're able to think. In binary, this is the binary representation. This is the first palindromic number. From this side also same, from that side also same. Second note says, do not consider the leading zeros while considering the binary representation. Now, this is a very important note because you guys know that this is also a palindrome, guys. 100% this is a palindrome, right? This is a palindrome, I agree, but he's telling leading zeros you cannot have, it seems. You cannot have leading zeros. Now, if I cannot have this as a 0, if this must be a palindrome, then if this is 0, don't you think even this has to be 0? If leading cannot be 0, obviously trailing also cannot be 0. Which means a very important observation I have, which is that if leading cannot be 0, trailing also cannot be 0, which means I cannot have any binary representation which starts with a 0 and ends with a 0. If it can't start with a 0 and end with a 0, the only other option is it must start with 1 and end with 1. Important point, which means this is acceptable, this is acceptable, this is acceptable. All these are acceptable. They are starting with 1, ending with 1. In between you can change in whichever way you want. But one thing I understood is all my palindromic binary representations are going to start with 1 and end with 1. Not because I said so, because the problem is asking you to not consider leading zeros, and the problem is telling you to start with 1. Hope you're able to think. Now that this part is clear to all of you, let me help you understand what I'm trying to say, right? So watch it, guys. Basically, now I'm going to write down all the palindromic binary strings. I'm going to write all the palindromic binary strings here, right? And through that I want you to understand something very important. First of all, I'm just bringing the different ways in which palindromes can look like. I'm just coming up with different ways, guys. I'm just coming out with different ways. Now look at this. This is a palindrome of length 1. This is a palindrome of length 1. So I'm just zooming it for your reference. This is a palindrome of length 1, right? So it can have only one combination. It can be 1 only, because in our case we cannot have 0. This is a palindrome of length 2. So see, whatever is the first digit, the second digit also has to be the same only. This is a palindrome of length 3. If you look at it, the interesting thing about a palindrome is that whatever is the first digit, same thing has to be the second digit. Which means these two are bound. The only change can be in the digit in between. I hope you're able to think. Similarly, if you look at a palindrome of length 4, this is bound to this. I hope you're able to think. Now, whatever you write here, same thing has to be written here also. Which means this is bound to this, this is bound to this. Anyways, this is bound to this, which means this will be fixed, this will be fixed. Whatever you write here only you have to write here. So in terms of options, combinations, what can you change is only this bit. Whatever is changed in this bit will be same next to it, and this will be anyways ones. Now we're able to think. Look at this. A and A are fixed. B, whatever you write here, same thing is written here, which means you can ignore these two bits, right? C obviously can change, which means when you're writing palindromic strings, binary representations of length 5, what you must keep in mind is that A and A will be fixed. Whatever the change you can do is in B, the changes you can do is in C, because whatever is there in this B will be copied here. I hope you're able to think. Any confusion? Look at this. A and A are fixed. B and C are the only options because this C is whatever you write here. This B is whatever you write here. How are you able to think? So again, only two combinations here which you can change. Rest is just copying. Look at this 7 length, right? Obviously A and A are same. Obviously this B can change, this C can change, this D can change. Now this C is nothing but what you write here. This B is nothing but what you write here. Which means in terms of combinations, how many combinations you have? 1, 2, 3 combinations. Only these 3 guys you can change. This and this are anyways fixed. This is the same as this is the same as this. And obviously this can be changed. So 3 combinations. If you look at 8, A and A is fixed, right? What you will write here? Same you will write here. What you will write here? Same you will write here. What you will write here? Same you will write here. In other words, how many things are you really changing? B, C and D. Same D here, same C here, same B here, and A and A is anyways fixed because you cannot have trailing zeros. You cannot have leading zeros. You cannot have trailing zeros also. So this is 1. All A's are fixed as 1s. How are you able to think? In between 0, 1, 0, 1, 0, 1 different combinations you can have. Any confusion till this point of time? Yes, we understood, sir. Great. Next what? Next what means now I want you to understand something. I'm writing the combinations. Watch it. First, I'm writing all binary strings whose length is 1, guys. Length is 1. Okay, so obviously I can have 1. That is the only thing because 0 I cannot have. So this is of length 1, and this is my first binary string. Coming to my second binary string, length 1 is over, so I can have 1 and 1, right? And this is of length 2. How are you able to think? Next comes my third binary string, and obviously here I cannot have a 0 because that is not possible. If this was 0, this also had to be 0 because you can see if length 2 means it has to be AA, this type only. Then so obviously here for length 1 combinations is 1, for length 2 also combinations is 1, then for length 3 basically it is this, right? A, B, A. A and A are fixed. A and A are fixed. B can change, guys. Now B can either be a 0 or can be a 1. Either can be a 0 or can be a 1, right? So if you look at this carefully, I'm just taking this for your reference and I'm just keeping it here. Now if you look at this carefully, how many combinations can you fit here? 2 combinations. You can fit 2 combinations, isn't it? So would you agree I can write this as 2 to the power 1? Because there are 2 combinations, 2 to the power 1 I can write. There is only 1 bit which can change. There are 2 combinations, so 2 to the power 1. This is the number of bits, this is the number of combinations. I hope you're able to think. So you have 1 position, 2 combinations. 2 to the power 1 combinations you can have. 2 to the power 1 is how much? 2. So totally, would you agree, I will have only 2 combinations. And hence, here 1 can be a 0, 1 can be a 1. I hope you're able to think. This is of length 3 and I have totally 2 combinations. Why you got these 2 combinations, I hope everybody understood. So this is my third one, this is my fourth one, now I will come to my fifth one. I hope everybody is able to see, I'm writing it also. Now fifth one means, now I have finished third, now I have to come to 4, right? If you look at 4, A and A is fixed. A and A is fixed. This B, whatever you write here only, you will write here also. So you have only 1 combination that you can change. This is just a copy of that, right? Which means, would you agree I can say like this, that there is only 1 position, that I have, and in that 2 combinations, 0 or 1. So again I have only 2 possibilities, which means, look, so easily I can write that 1 and 1 are fixed. 1 and 1 are fixed. Now B can be 0. Whatever I write here, same I should write here. B can be 1. Whatever I write here, same I can write here. Any confusion till this point of time? So this is again of length 4 and I have 2 combinations. So this is my 6th one. Then coming to my 7th one, 2 combinations are done. So I have to increase the length. If I increase the length, now I have to go for 5. Look at 5 and please try to understand what I am saying. A and A are bound. Whatever I write here B, same B will be used here. So you can ignore this B also. This C can change. So how many positions do I have that can change is these 2 positions. Would you agree with me? So would you agree, in a way I can tell that I have totally, how many, basically 2 options, and how many positions do I have? 2 positions. 2 to the power 2 is nothing but 4, which means how many options will I have? How many combinations will I have? 4 combinations, which means, see here, I am writing it, okay? 1 and 1 fixed, 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 4 combinations, right? Now, ignore this bit here, ignore this B here, right? It will be anyways whatever we write. This B and C is what I can change, so I am just writing it, see? 0, 0, 0, 1, 1, 0, 1, 1. Oh, interesting. Looks like that binary sequence. And look at this. This is B, isn't it? Whatever you write here, you should write here. Whatever you write here, you have to write here. Whatever you write here, you have to write here. Whatever you have to write here, write here. That's why I told you. This and this are bound together. This and this are bound together. This and this are bound together. I will be able to think. So, correctly, how many combinations I've got? 4 combinations. And what is the length of each combination? 5. And totally the number of combinations I have is 4. And then just writing, this is 8, this is 9, this is 10. Similarly, I am writing 11. Okay, now obviously I have to increase it. If I increase it, this is the next one. Listen to me carefully. Now you guys only have to tell me how many combinations, boss. Look at this. A and A are fixed. Whatever you write here, same thing you have to write here. So this is also gone. Whatever you write here, same you have to write here. So this is also gone, which means these are the only 2 combinations you have to work with. These are the only 2 combinations, right? Which means you have I'm just marking those 2 combinations for you. That is, you have this and this. So totally 2 options and you have 2 positions, which means 4, again 4. So if you notice, I'm just writing it for you, okay? This is of length 6. So 1, 1, 1, 1, 1, 1, 1, 1. So totally 4 combinations, okay? Then only these 2 guys I can change. So I'm writing all their combinations 0, 0, 0, 1, 1, 0, 1, 1. I will be able to think. Whatever I write here, same thing I should copy here. Whatever I write here, same thing I should copy here, because see, C and C. Whatever I wrote in B, same thing I should copy here, which means I will get 0, 0, 1, 1. Are all of them palindromes? Yes. So I am teaching you how to generate this palindromic sequences. Okay, so this is my 12th one, this is my 13th one, this is my 14th one. Any confusion till here? So totally, how many combinations did you have here? You had a total of 4 combinations and length is 6. Any confusion till this point of time? Now, similarly, you would like to write for 7 and 8 as well. Okay, let me just show you. Watch it, my dear friends. I've written everything down for you. We completed till length 6, right? Now let's go to length 7. Now if you notice something interesting about 7, 7 means this is the pattern, A, B, C, D and C, B, A. This is the pattern, right? So if you look at it closely, you will notice one thing, that for A I don't have an option, right? A and A boundaries are fixed. Now for B, certainly I have an option. Now whatever I write here, I have to write here. So this bit really does not have any option, it's just a copy. For C I have option. But whatever C I write here, same thing I should write here, which means this bit doesn't have an option, it's just a copy. D certainly has an option. I hope you're able to think, right? So out of 7 bits, only 3 bits can have options of changing. Others are just a copy of the options. I hope you're able to think. Which means totally how many combinations can happen if there are only 3 positions that can change, each with 2 permutations? Well, it's very simple. It is 2 to the power of the number of positions, which means 8 combinations, and exactly you will notice 8 combinations. And these are the only 3 bits that can change, and see, those are the only 3 bits: 000, 001, 010, 011, 100, 101, 110, and 111. These are the things that is changing. And I can also prove to you, see here guys, whatever is there in this B, this is only B. Same thing is there here. Same thing. Whatever is there in the C, same thing is there here. How are you able to think? And of course, D is different. So it is not that it is different. It is following this pattern only. 100%. Now that you understood this, I am sure all of you would be able to tell me that certainly how 8 works. I am sure everybody will be able to tell me how 8 works. 8 pattern will be ABCD, DCBA. ABCD, DCBA, right? Which means A and A have no options, they are fixed. Of course, B can change. Whatever you write here, same thing you'll have to write here. Of course, C will change. Whatever you write here, you'll have to write here. Of course, D will change, but whatever you write here, you have to write here, right? Which means totally there are only 3 positions. Each position can occupy 2 values, which means 2 values and in each position and 3 positions, which means 8 combinations, and 100% there are 8 combinations. And you can see 000, 001, 010, 011, 100, 101, 110, 111. And whatever you told in this position is what you are telling in this position. Whatever you told in this position is what you are telling in this position. Whatever you told in this position is what you are telling in this position. So is it not following this? 100% it is following it. I hope you're able to think. Hence, I hope if somebody tells you, hey, listen, please give me all the palindromic binary strings of a given length, easily you will be able to first predict how many combinations, and you will be able to write all the combinations. So totally you can see till 30 combinations I have written. Starting from 1 all the way I have written till 30. Till 30 I have written. Now one more important point I want to show you. If you look at this, length is 1, combination is 1. Length is 2, combination is 1. Length is 3, combination is 2. 4, 2, 5, 4, 6, 4, 7, 8 and 8 and 8. Which means one thing you are noticing, 1, 1, 2, 2, 4, 4, 8, 8. So length 1 and 2 both 1 combinations, length 3 and 4 both 2 combinations, length 5 and 6 both 4 combinations, 7 and 8 combinations, 9 and 10 will have the same number of combinations, 11 and 12 will have the same number of combinations. I hope you are able to see. Now the thing is, to solve this problem, it becomes very important for me to express the number of combinations as a function of the length. Or from the length I should be able to derive the number of combinations, because you can see length grows linearly, 1, then length 2, length 3, length 4. Somehow I can keep track of length and I can keep incrementing the length. But it will be really good if through length, if I can find how many combinations exist for the length, then I can start to develop an algorithm. Okay, sir, how is there a correlation, you may ask? 100% there is a correlation. See, I'm just writing it here for you. I'm just writing it here for you. Would you agree that this can be written as 2 to the power, what is the length? Length is 1, 1 minus 1 divided by 2. 1 minus 1 is 0. 0 divided by 2 is 2 to the power 0, which is nothing but 1. Here also I can write 2 to the power length happens to be 2 minus 1 divided by 2. 2 minus 1 is 1. 1 divided by 2 is 0. Again 2 to the power 0 is 1. Similarly, this is nothing but 2 to the power length minus 1 divided by 2. 3 minus 1 is 2. 2 divided by 2 is 1, which is nothing but 2 to the power 1, which is nothing but 2. 100% if this is 2, this also can be 2 to the power 1. This would all of you agree will be 2 to the power 2. This all of you agree would become 2 to the power 2. This all of you agree would become 2 to the power 3. This all of you would agree would also be 2 to the power 3. Which means in general, what am I trying to say? In general, what I'm trying to say is that the number of combinations, I'm just writing it here, number of combinations. If I have to express it as a power of the length, then it is 2 to the power length minus 1 divided by 2. It will work for everything. Definitely it will work for everything. So there is a way to extract the number of combinations for a given length using the length. There is definitely a way. I hope till here how to write the different palindromic strings keeping the rules in mind and how to derive the number of combinations using the length you have been able to understand. Now using this, I am going to take you one step forward. Listen to me carefully. N, let us assume, is 21. This the user will give you. Your output ultimately should be the 21st palindromic binary string. I have listed the numbers down here. If you look at it, which is your 21st palindromic binary string? This is 21. So it is 1110, 111. This is what should be given as the output. Of course, in output we will convert it into decimal and print it, but ultimately the binary representation should be this. Now, how will we get this? Now tell me guys, common sense tells me that it doesn't matter which number is given to me. It doesn't matter unless until I know the length of this 21st or 51st or 8th or 7th or 5th, doesn't matter. Unless I know what would be the length of that palindromic string, I will not even be able to start, because, watch it, if in case I know that the length is 7, I know that the palindrome will appear in this pattern only, A, B, C, D, C, B, A. Would you agree with me? Which means what I can do is, I can just go here and if in case I get the length, assume, if in case I get the length, right? So this is the length. I'm just asking you to assume. So the length we know is 7. How to get this length, sir? I will tell you. Assume we know the length. If we know the length, then I know this is how it will look. Yes, I have 1, 2, 3, 4, 5, 6, 7 bits. I know that because it is of the form A, B, C, D, C, B, A, I know the first bit has to be 1. I know the first bit has to be 1, right? Also, if you look at it interestingly, if you look at something, look at this. Look at all the combinations of length 7. Look at all the combinations of length 7. You know that ultimately only 3 bits can change, others are just copies. So these are those 3 bits. Let me just mark those 3 bits for you. I am just putting a boundary around those 3 bits for you. I am just putting a boundary. Just putting a boundary. Look at this. Okay, now you will observe something interesting. 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0, 1, 1, 1. In other words, don't you think it's following the binary sequence? In decimal, if I convert, what is this? 0, 1, 2, 3, 4, 5, 6, 7. 0 to 7 means it is 8 numbers. There are total of 8 combinations. Length is 7. Length is 7. Which means, if in case I find the length, right? In the length, if I can find out in that length, in those 8 combinations, which is that combination that my number appears in, which is this. If I find out, then clearly I can tell 1, 1, 0. This is what should come. This is what should come, which is nothing but 6, which is nothing but 6. Now, if I can take this 1, 1, 1, 0 and if I can place it here, if I can place it here, rest everything anyways is zeros. What is the advantage, sir, you may ask? Look, I'm going to show you another magic. I will just take this and I will reverse it. If I reverse it, it will be 1, 1, 1, rest everything will become zeros. And if in case I perform OR operation, then look at this and tell me, what will you get, guys? If I perform OR operation, 1, 1, 1, 0, 1, 1, 1. And would you agree, this and this are nothing but one and the same. 21st number is nothing but this. So, one thing is clear. Given a number n, right, you need the nth palindromic binary string. For that, first you need length. If you know length, then amongst the number of combinations of that length, if you can find the position that it appears in, this binary equivalent if you can get, take that and place it here, reverse it and do OR operation, you will get it. It is as simple as that. It is as simple as that. Would you agree with me? Which means, first thing I want to find out is how to find out the length. Second thing is, if I need to find the position in which this binary sequence appears, then would you agree that I need to always put myself here, that is this 14th position. If I can find the previous combination's last number, if I can find the previous combination's last number, from there I can start my count. 1, 2, 3, 4, 5, 6, like I can start my count. I'll be able to think and I can apply it. So, how will we be doing that? How will we find out the length, number one? Second is, how will we find out the count of combinations? See, the count of combinations till this point is 14, which means the previous length's last combination was 14. I hope you're able to think 14. From there, I have to now find out this particular value. I hope you're able to think. How are we going to do that? So, first, I need to find out the length. After finding out the length, I need to find the total number of combinations which occurred till the previous length. So, if length is 7, till 6, what was the previous one, which is 14? I need to find this out. How are we going to do that is the question, isn't it? Now, watch it. Let us assume that I don't know what is L. I am going to create one variable called as count, friends. And let us assume that this count variable also I don't know. I don't know. Both I will initialize it to 0. This is also 0, right? And this is also 0. Both are zeros. Any confusion till here? Great. Now, how are you going to go about finding it, you may ask? Very, very simple. Let me quickly just erase all this for you. First, you want the length. What I will do is, I will do like this. Initially, I will increment length because it is 0, right? So, I will increment it. If I increment it, length is going to become 1. Would all of you agree? Now, for the first length, I want to count how many combinations are there. For the first length, there is only one combination. Now, length is 1. Using 1, can I find out the number of combinations? Yes, because we have already derived it. If you have length, 2 to the power of length minus 1 divided by 2 will give you the number of combinations. Look at this, it is 5. 2 to the power of 5 minus 1 is 4. 4 divided by 2 is 2. 2 to the power 2 is nothing but 4. So, if you know length, you can find out the number of combinations, which means for that length to find out the count of the number of combinations, all I have to do is I should update the value of count by telling count plus equal to, what is plus equal to? Count equal to old value of count plus what? Number of combinations. How will you find this? Simple. Take the power of 2 to the power length minus 1, which is L. Length is nothing but L. Length minus 1 divided by 2. That's it. you will get count. Now watch it. I will increment the value. I will loop this. I will increment the value of L. L becomes 2. Now for 2, how many combinations I need to find out and add that to the existing value of count. First of all, if I do this, count is going to become 1. Count was 0. For one length, there is only one combination. So 0 plus 1 is 1. Okay. Now length became 2. Now for 2, how many combinations I want, and I want to keep that total count here. So how will you do that? Simple. Existing value of count is 1. 1 plus power of 2 to the power of length minus 1. 2 minus 1 is 1. 1 divided by 2 is 0. 2 to the power 0 is 0. So 1 plus 1 is nothing but 2. Are we able to think? Great. I will again increment count. Now I want to find out how many combinations are there for length 3, update it to the total count. And if 3, then you will have totally 2 combinations. So 2 plus 2 is nothing but 4. Then I am going to do, I will make it as 4. If I make it as 4, then you have total of 2 combinations. So 4 plus 2 happens to be 6. Then I will increment length as 5. If I increment length as 5, then all of you know that for 5 you have a total of 4 combinations. So 6 plus 4 will become 10. Then I will make it as 6. If I make it as 6, then obviously for 6 you have a total of 4 combinations. So 10 plus 4 is 14. Then I will make it as 7. Length will increment, it will become 7. If it becomes 7, even for 7 the total number of combinations is 8. So 14 plus 8 is nothing but 22. Now you may ask, when will you keep going? Will you keep incrementing? No. My intention was what? For the given value n, I want to find what will be its length. We know for 21 it is going to be 7. We got 7. Correctly we got 7. The moment you get 7, you must stop. So what is the condition you can write here such that the length will only keep incrementing till it becomes equal to the length you are looking for and not more? If you look at it, we have not yet reached our length. Look at the value of count. It was lesser than n. We have not yet reached length. Look at the value of count. It was lesser than n. Length, count 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 is greater than n. When it became 7, count became greater than n, which means, would you agree that this particular part, this part, must only be performed as long as a certain condition is satisfied. What is the condition? The condition is that the value of your count is less than n. As long as this is true, you loop it. The moment count value becomes greater than n value, you must be 100% certain that you are found the correct length. And definitely this is 7, and you can see it is 7. Any confusion till this point of time? So if I run a loop like this, I found the length of my given palindromic binary representation that I want. But look at the count. The count is 22, friend. What did I tell you? We have to find how many? We have to find the last combination, the previous lengths combination. I want count to be here, 14. If count is here, then from this position I will be able to come down and find the right position which I want. That is how I will be able to find this. But the point is, I need this count to be here. Very simple. When you came out of the loop, count was 22. If I can just bring count back to its previous value, if I can bring count back to its previous value is 14, and that is what we also wanted, 14. I hope you are able to think. So, would you agree that the last iteration, when I did count equal to count plus power of 2 to the power L minus 1 divided by 2, from 14 I became 22. Now when I come outside, if I wanted to go back to its previous value, all I have to do is I will tell, hey, count minus equal to power of 2 to the power length minus 1 divided by 2, which means what happened in the last iteration, I'm undoing it. If I undo this, count is now going to go back from 22 and it is going to become 14, which means when n was given, you have successfully found the length that palindromic string is going to have, and you found that the previous length, for the previous length's last combination, what was it? 14. You got both of this. Now all that you have to do is, using this length, using this count, you must be able to generate this. How are we going to do that? Let me show you. Now let's continue with the algorithm. Listen to me carefully. Length we found out, and also we found out that before the given length, that is if n is 21, we know length is 7, but before the length 7, how many palindromic numbers are there also we found out. That count also we have, and that is correct. See, these are length 7. Before length 7, there are till 14 you have. So you got this also. Now the beauty is, because you got that number 14, right, it becomes very easy, because ultimately your n value is 21. Your count is 14. You want this number. Now, you know ultimately that length 7 means the combination will be A, B, C, D, C, B, A. I hope you're able to think. And you also know that only these 3 bits can change. I have elaborately explained it. Only these 3 bits can change. Whatever is there here will be written here. Whatever is there here will be written here. A and A is anyways bound. So only this B, C and D can change, right? Which means that is what we have also marked here. So 0, 0, 0 is the first number in the combinations of length 7, right? 0, 1, 2, 3, 4, 5, 6. You need this. This 1, 1, 0 you need. If you get this 1, 1, 0, then using that 1, 1, 0 you can construct the rest, because rest is just copying. You know first bit is fixed. You know last bit is fixed. Only these 3 will change. If you know these 3, you can create the rest of it easily. So the question is, how do I get this 1, 1, 0? 1, 1, 0 in decimal is nothing but 6. Now, how will you get it? You can only work with what you have. What you have is n, what you have is L, what you have is count. Now watch it. Using the given n value and the count that you have calculated, which as of now is 14, you will easily be able to, using n and count, get that value. You want to see how? Very simple. Focus and listen to me carefully, guys. I want everyone to focus, okay? See, you are here. This is your count. This is your n value, right? You want this 6. 1, 1, 0 is nothing but 6. So see what I will do. I will do n minus count. N minus count. Because count means till here you have. N value you have. You want this till here, what is the difference you want to know. So n minus count, if I do, see here, I'll do n minus count, which means n happens to be 21, count happens to be 14. 21 minus 14 is 7. I hope you're able to think. But this is not 7, sir. We want 6. Oh, you want 6? And very simple. Do minus 1. Are you able to think? And 6 is nothing but 1, 1, 0. Would everybody agree with me? 6 is nothing but 1, 1, 0. I hope you're able to think. So, how will you get this value? Let us call this value as element. Let us call this as element, okay? So, let's just call this value as element. Let's just call this value as sorry about that. We'll just call this as ELE. We'll call it as element. You want this element. How will you get this element? Element is equal to n minus count minus 1. Now, beautiful. Many things you have got. So, using this element, how are we going to do it? Let me show you. Okay. Now, you know that this is the loop which you will have to run in order to get your L and count. Anyways, I am going to minimize it and keep it here. Right. Let that be there. Now, listen to me and listen to me carefully. Watch it, guys. Now that I know length is 7, do you agree that I can do something like this? I have 7 length, right? I'm just showing you. 1, 2, 3, 4, 5, 6, 7. I know length is 7. Now, how will I construct this string that I have? I have n, I have L, I have count, I even have my element. Now, how will I construct this palindromic string? It's very simple. All of us know that the first number has to be 1. This is guaranteed. First number has to be 1, right? If this first bit has to be 1, then how will you set it as 1? So, your length is 7. How will you set the first bit as 1? Very easy. Would you agree? I can do something like this, where if I first write 1 in binary, 1 in binary is this. Now, look at it carefully, right? Shifting operation if I do, I can bring 1 here. Now, let's see how many times we have to shift. I have to shift it once, I have to shift it twice, 3 times, 4 times, 5 times, 6 times. Totally 6 times if I shift 1, 1 will come here. So, very simple, because we know that irrespective of what is the length, first bit is going to be 1. Now, how am I going to do left shift operation on 1 such that it will come to the first position? How will I do that? Obviously, you must write it in general in terms of the length. It is the length which will decide how many times shifting should happen. Now, let us assume I do something like this, right? I do something like 1, 1, left shifted by a total of L times. What is L? 7. But how many times shifting should happen? 6 times. So, would you agree? The number of shiftings that must happen is always 1 less than the length. So, would you agree? I can say L minus 1. Would everyone agree? Now that you know the length, easily you can set the first bit as 1 by taking 1 and performing left shift operation L minus 1 times. 7 minus 1 is 6, and here 6 operations should happen. I'll be able to think. So, how to do this you understood? How to set this you understood? Great, you have set it. Now listen to me carefully. I am just going to erase this. Setting you have done. Now, next thing that you must understand is, you have this element. This element is nothing but 110, which is nothing but decimal 6. Now, this 110, I have to somehow place it here. This 110, I have to somehow place it here. Would you agree with me? Because that is how our 21st number looks, 1 followed by 110. How am I going to put this? Very simple. As of now, what is there in this element ELE? I am just going to write it here for your reference. I have ELE, and inside ELE, I have 6. 6 is nothing but 110. How are you able to think? Now watch it carefully. What we have to do is set this 110 here somehow. Obviously, you can't directly set it. It's all bit manipulations. How to do it, I'm showing. See, right now, after you took 1, shifted L minus 1, 1 is here. All these positions, you actually have zeros, my friends. You have zeros, okay? Now, this 6 is nothing but in binary 0, 0, 0, 1, 1, 0, like this. Ultimately, if you want this 110 to come here, you must shift it, right? See, that's what I'm also showing you. All you have to do is perform shifting. See, I'm just showing this, right? So, if I do like this, this is 110. If I shift it once, this is how the bits will look. If I shift it 2 times, this is how the bits will look. If I shift it 3 times, this is how the bits will look. And if I take this and if I place it here correctly, it will come. I'll be able to think. So, it's ultimately shift operation that you will have to perform, right? So, how many times did I shift, friends? How many times did I shift? I shifted for a total of 3 times. Now, how will you know how many times shift has to be done? I am just writing it here. Ultimately, what you had to do was, you had to take your element and you had to do shift operation. But how many times you have to do shift operation? Again, in general you have to write. In general you have to write. Again, in terms of length only you have to write, because it has to be an operation which depends upon the length, because as the length changes, the shift operation also will change. Now, how? Very simple. Look at this. Length is 7. You want 7 to become 3. Would you agree if I do 7 divided by 2, that is nothing but 3, floor division. Of course, it's 3.5, you can ignore it. So, this is L, which means in general I can write L divided by 2 times. Definitely it will work. You take for any combination, you take for any length. The number of times this element will have to be shifted will be length divided by 2 times, 100%. And hence I am saying you have to now perform shift operation L divided by 2 times. If you do that on element, what will happen is like this shifting will happen. 3 times means 1 bit, 2 times, 3 times. And correctly if you do, all these zeros will go, right? And you will have zeros here. Now if you look at it carefully, one thing you will observe. What will I observe? I want to merge both of them. If I merge them, what will happen is, see, like this I will get 1, 1, 1, 0, 0, 0, 0. Like this I will get. Now what is the operation I can apply between both of them? OR operation. What is the operation I have to apply? OR operation. Now we're able to think. Simple. So see here, that is what I am also saying. If I do OR operation, I will get this, and you can see you have got 1, 1, 1, 0, 1, 1, 1, 0. These last 3 bits you have to set it to complete it, but half of it you got. From literally not even understanding the question, successfully you have been able to set at least half of the palindromic representation. Now we're able to think. Amazing, isn't it? How to set the other half also I will show you. But I would like to store this within a variable called as answer. Right? So how will you find this answer? Very, very simple. What you have to do is perform OR operation between single, right? So I'll just write OR like this. OR operation between 1 left shifted L minus 1 times, so that this bit is set as 1, or and take the element left shifted by L by 2 times, so that this part, this sequence comes and sits at the right position. How are you able to think? If you do that, you got answer. 90% of your solving of the question is done. Now from this answer, you have to now generate the complete answer. Now, how will you generate the complete answer? Well, it's very simple. Now that you guys understood this, let me just write it like as an algorithm and show you guys. Let me just write it as an algorithm. See, ultimately, you are given n. From n, you want length and count, right? So you need to find length and count. How will you find length and count? This is how you will find length and count. This is how you will find. So this is your step 1. This is your step 1. What is your step 1? Find length and count. This is my first step. How are you able to think? Let me erase this also. Oops. Let me erase this. You found length and count. Now, what is your second step, boss? Think and answer. Your second step is length and count you got. Now from length and count, you want this combination, which we are calling as element. Okay. So you need to find the element. How will you find the element? Everybody knows. All you have to do to find the element is you have to tell element is equal to n minus count minus 1. I have explained this also to you. Great. Next, third step. Now that you found the element, using the element, you have to now create that answer variable, right? So, create answer. How do you create that answer variable? Very simple. Answer is equal to 1 left shifted L minus 1 times OR operation with element left shifted by L divided by 2 times. L divided by 2 times. I hope everybody is able to think about what I am saying, right? Let me just shift this a little bit here, right? This is only your answer. 3 steps are done. But ultimately, this answer will not be complete, because right now, what do we have? We have our 7 bits, 1, 2, 3, 4, 5, 6, 7. We set this as 1, this as 1, 1, 0, and we got 0, 0, 0 like this. This is only half the answer. It is not the complete answer. How are we going to take this and make it into the complete answer is your step number 4. And to show you step number 4, let me show you something interesting. Okay, I'm just copying this, right? Watch it. I'm just pasting it here. Now I'm just talking about the last and final step, which is your step number 4. This is my answer. If you look at something interesting, if I take this answer and if I were to reverse it, I've reversed it. After reversing it, if in case I were to perform OR operation, then you will notice this will become 1, 1, 1, 0. This will become 1, 1, 1. And would all of you agree that is exactly the combination 1, 1, 1, 0, 1, 1, 1. So that is the beauty. It is A, B, C, D. Rest is the same. Rest is the same as this. If it is the same as this, all you have to do is reverse this. Reverse this, perform OR operation. It is just the reverse of this. Are you able to think, right? See, this is A, B, C. D is fixed, you leave it. A is also fixed, right? So if I take A, B, C and write it as reverse C, B, A, I will get the output. As simple as that. Look here. If it was 8, it is A, B, C, D, D, C, B, A. Which means if I take this A, B, C, D, reverse it and attach it here, it becomes D, C, B, A. How are you able to think? So, A, B, C, take it, OR it with this. These bits were anyway 0. These bits were anyway 0. All you have to do is reverse it. If you reverse it, this A, B, C bits came here. Now you want them to get merged, do OR. You got it. Which means, how will you write this final step? This final step is nothing but if I have to write it as code, I will tell my new answer is equal to my old answer OR with reverse of my answer. I need to reverse my previous answer. Would you agree with me? So that is my 4th and final step, which is doing this OR operation. But before we do OR operation, the larger question is, how are we going to take this and reverse it? How to do it? Let me show you. Now let's write some code. Very simple. These 4 steps you have to implement. This is my function which returns an integer nth palindromic binary. Okay, so I'll come inside it and all I'm going to do is step number 1 to find the length and count. So I'll create integer variable L whose value is 0 and count whose value is 0. Okay, great. Next, all that you have to do is now run a loop through which you can find the length and the count. And you know how the loop looks like. So if I have to just show this to you, as you can see, this is how the loop looks like. So as long as count is less than n. Then what you have to do is go inside, increment the value of length, and then for that particular length, how many combinations are there? That is what you have to count, which is nothing but count equal to count plus how many combinations are there is nothing but we have expressed this as a power of 2 to the power length minus 1 divided by 2. All this we have already proved it to you. So math dot power function I will call and I will tell 2 comma L minus 1 divided by 2. Great, amazing. Next I will come outside. Okay, this wait. Why did we do this? We are doing this because see it's giving us an error. It is telling hey, this RHS is giving me an double value, but you're trying to store it inside an integer value, right? That's not possible. So why? Because power function always gives you a double, so please typecast it to an integer. Great. Next I'll come outside and as I've previously explained to you that the count, we need the count till the previous length's last element, isn't it? But because this loop would have worked one extra time. The last time what incrementation happened, we must remove that from count. So see, I'll just copy this line. I'll just copy this entire line, paste it, and all I will do is I'll tell, hey, from count, you don't add, I'll subtract. I'll subtract the last value, and this in detail I've explained. If you want to, you can just rewind and watch it again. Great. Now what we have to do is, we found length and count. Now using length and count, you must find the element. So I'll tell int ELE is equal to n minus count minus 1. N minus count minus 1. This will give you the element. From the element, you can calculate the answer. Answer is nothing but 1 left shifted L minus 1, so that the first bit can be set as 1, and then this element should be set as the next 3 bits, so that can be done using an OR operation and shifting the element by length by 2 times. So that's what I'm telling. Int answer is equal to 1 left shifted L minus 1 times. And this I will OR it with element left shifted length divided by 2 times. Length divided by 2 times. Great. That's about it. That gives you an answer. Now this is only half the answer. Now you have to take this answer, reverse it, and OR it with each other, and that is what I have shown you. You must take the answer, reverse it, and perform OR operation. Now how are you going to reverse this answer, right? That we will see, because previously I have taught you how to reverse a binary number. We will use that. Some modification we have to do, but we will use that. Anyways, you know how to reverse. Anyways, I will just tell answer equal to the previous value of answer, OR it with, and I'll call this reverse binary. And to that I will pass answer. Hope I'm clear. Now this is your final result, return it. Now let us go to the reverse binary. If I go to reverse binary, one thing you can see here is the first pointer is at 31. The last pointer is at 0. I hope you're able to understand that. Now this is because we were trying to reverse a 32-bit binary number. But now we are trying to reverse a binary number whose length is L. It's decided by L, right? It could be of any length. So what should we do here is, we will not make it as 31. See, if it was 32 bits, it was from 0 to 31. If it is 7 bits, it should be from 0 till 6. 6 is nothing but L minus 1. So that F I will make it as L minus 1, like this. Okay, so now we need this length here, right? Now, so remove that, make it L, make it L. Okay, sorry, we can't make it L because we already have L used here. We'll make it as length minus 1, otherwise variable names will clash. Now, where is this length? This length is inside this nth palindromic binary number. So, all I will do is, I'll go on top and I'll make this reverse binary accept one more argument, one more input, which is the length, int length I will tell. Right, now where is this length? Simple, come down. While you call reverse binary, pass your answer and also pass your L value, which you already know. Okay, why I didn't call it L there is because we already had first and last. Last L was last. Okay, good, great. Now that's about it, guys. This is the code, right? But 35 lakh package question this is, right? But to think and arrive at this logic, I had to break it down, and I sincerely hope all of you understood the logic, right? But it is equally important that you go type, practice, and try to derive it from scratch on your own. And whenever you get stuck, this class will act as a reference for you, as a guide for you, as a light for you. I hope you're able to think. Anyways, will this work? Let's go check it out. So if in case I execute, then if I put 21, if I press enter, I got 119. But we don't know whether it is correct or not, because we want to see the palindromic representation, right? And actually the 21st palindromic number looks like this. To see whether these two match, I will just come down to my code, and there, instead of printing instead of printing this decimal value, I would like to print the binary string. So there is a built-in method to do that. So I'll just cut this, and the built-in integer class has a static function, which is this to binary string. To that I will pass whatever the function returns, right? Now if in case I go and if in case I execute it, let us see whether this will be the expected output. So if I go there and if in case I put 21, then 1110 111, absolutely right. Let us assume the 15th palindromic or let us assume the 12th palindromic string I want. It looks like this. Let us see whether we will get the right answer. If in case I execute and make it as 12 and press enter, it matches. So it works. So go on ahead and impress those Amazon HRs, and I will catch you in the next class.